So in starting out with kinematics, you will see a lot of this quantity versus another quantity in this chapter. So the first of such divisions is the difference between distance and displacement, right? So these are some quantities that we'll be talking about in this chapter, later maybe also in the form of graphs. So first let's just talk about what all of these quantities individually mean. So distance is defined as the total length which is covered by a moving object, right? So any object, when it's going to move over some length, right? It's going to cover some length, and whatever length it covers, that total length is what we call the distance. And from real life, we actually have a pretty good idea of this as to what distance is. So for example, you might know that in going from your home to your school, you might have some idea of the amount of distance that you cover. Maybe your car tells you that from that meter near the speedometer. So you have an idea of distance, and displacement is only slightly different, even though the definition might seem more complicated. So just bear with me for a moment. So displacement is defined as the shortest distance between two points from some reference. So don't worry, the definitions of these will never be asked in your exams, but what's more important is the understanding of these, which actually will help you later in more advanced concepts. So displacement is the shortest distance between any of the 2 points, and there needs to be some reference from which the displacement is being measured. So let's have a quick example of this. So for example, if someone says to me that you can move, so let's say I'm standing here at this position, and someone says to me you have to move 5 meters, right? So if someone comes up to me and tells me to move 5 meters, I can move 5 meters in any direction I want. I could move like this or this or this or this or this or this, right? Whatever distance I move, I can cover 5 meters in any of these directions. So I can move like this or this or this, right? Or in any other direction, possibly an infinite number of directions, all of which you can also think about this in terms of loci. So this basically forms a 5 meter, a circle with a radius of 5 meters. So I can move from the center position to any of those positions like that. But if someone comes up to me and says to me that you have to move 5 meters east, right? So then I'm restricted. So if I'm at this position, I can only move towards the east, which is the right. So now I can only move towards the right. So this is really the difference between distance and displacement. Displacement has direction with it as well, whereas distance does not have any associated direction with it. And now we know from our previous studies as well, how do we talk about quantities which do need direction. So we call those quantities vectors because it needs direction. On the other hand, distance is a quantity does not need direction, right? It's the total length, whatever is covered by a moving object. So we do not need any associated direction. This is just a scalar quantity, right? So this needs direction, but distance does not need direction. So whenever we talk about displacement, this was also written above. This is always from some sort of a reference, right? So let's do an example, and this will quickly clarify these concepts for us. So let's talk about an example. So let's say we have a scenario like this. This is a car, and it travels between all of these intervals, right? So let's say that all of these intervals are equally spaced and all of these are 10 meters apart, right? So this car travels 10 meters every second. So it starts out from this position O. So O is a symbol which is commonly used for the starting position. It basically means origin. So this is where it starts out from. This is the origin, and then it moves like this. And then at this point, it basically does this, that the driver of this car switches the gear to reverse, and then he goes back in reverse, right? But obviously on a 2D diagram, that's not very easy to depict. So I've made this below, but really it's not like this is a U-turn. He just goes back, he just goes to the front, goes till here, and then reverses the car and goes back like this. So what we need to do is we need to draw a table, right, basically of how the distance is changing and how the displacement is changing. So distance and displacement, how are they changing with respect to time? But remember that displacement is a vector quantity. So for a vector quantity, and for displacement more particularly, you need a reference from where this is going to be measured. So it's measured from O. But again, with vectors, you also need to define, since the direction is important, you need to define where will it be measured as positive and where will we take it as negative. You'll also encounter this concept later, and you've also probably seen this, but you never realized it. So right now I'm going to say that the displacement, so the displacement is measured east of O, right? How far to the right of O is the car is how the displacement will be measured. So the displacement is measured east of O, right? So now let's think about this. So in the first interval, again, we are taking this as a reference of the car. So previously the rear end is at O, and now this car moves ahead to a position like this, right? So from 0 to 1, the distance covered has also been 10 meters, and it's now 10 meters to the right of O, so the displacement is also 10, right? Next. So in the next one, it again goes 10 meters further to the right. So in another second, it traveled an additional 10 meters, and now it's 20 meters to the right of O. So this is going to be 20. In the third second, it goes further forward like this, right? Now it has traveled another 10 meters. Actually, I should have made this 20. So it was 20, and now it's traveled another additional 10, making the total distance 30. And now it's 30 meters to the right of O, right? Till here is 30 meters to the right. So this is again 30. So 10, 20, and 30, right? Actually, I should then get rid of both of these. And now what's going to happen is now the driver is reversing, and he comes to this position of this sort at the 4th second. So at the 3rd second, after reaching that point where the rear end was here, he reversed, he put the car in reverse and he brought it back here. So now if we think about what's going to happen to the distance again has increased by 10 because it's just traveling that, right? First it was here and then it came 10 meters further back, so the distance is increased by 10. It's become 40, right? It's still traveling, right? Any moving object will always cover some distance. So it moved and it covered more distance. But the displacement now, since the displacement was measured to the east of O, now it's only 20 meters to the right because it came closer towards where it started from. So the displacement is now going to decrease. It's now 20. Next, if it's going to move further back again like this, So now again it has traveled an additional 10 meters, making the total distance increase by another 10. But now it's only 10 meters to the right of O, so this displacement is going to be 10, right? It's only 10 meters to the right. And now you can probably guess that if I bring this further back till this position, it has traveled another 10. So the distance increases by 10 again, makes it a total of 60. And now the displacement is 0 because it was measured to the east of O, right? The displacement was being measured to the east of O. If it's already at O, then it's no distance to the right. It's basically back where it started from. So in this case, the displacement is 0, right? What if I take it further back? So now that the rear end coincides with this mark, which is again also 10 meters. So again, the displacement, the distance first, let's talk about the distance, again increases by 10, but the displacement is now negative 10, right? And why is it negative? Because it was measured to the east of O, right? We were talking about how far to the right of O the car was, but now it's to the left. So if we are saying the displacement to the right or to the east of O is positive, then that means that the displacement in the opposite direction would be negative. So at this position it would be negative 10, and then similarly you can guess for the last position the distance would increase by 10 more and the displacement would become minus 20 as it moves further back to a position like this, where it coincides with this mark. So one thing that you learned from here, if you look at the table again, is that the displacement was 0 when it was back at its starting position, right? And it actually fits in perfectly well with the definition for displacement, because we said that the displacement is the shortest distance between 2 points from some reference. So for now, let's ignore the reference part, but it's between 2 points, right? But what if both of the points are the same point? Then there is no distance, right? So remember this always. I'm writing this here. So displacement is 0 when you return to the starting position. Right? Next. Or actually, before going to the next one, it would also apply to a scenario like this. So for example, if we have so let's say this is a track in a park, right? Let's say this is where you start off from. You start from this point, let's call this one O, right? Let's say you walk around this circular park, the track of this park, you go like this, 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 and all the way back here. Obviously, if this is a very large park, you would be exhausted by this walk, but your displacement would be 0. So the idea is that if you go from here, travel all this distance, right? You have traveled some distance because you were moving, you covered some length while moving, but since you return to the original position back again, the displacement is 0, right? So in a round trip, and what I mean by a round trip is when we return to the original position, the displacement becomes 0. Let's have a look at another example to further understand this concept. Let's say that this is your home and this is your school, right? Fortunately, you live very close to the school. So let's say that this distance is like 600 meters. Let's say this distance is 800 meters, right? So this is maybe like a corner where you turn left to reach the school. So if I ask you that you went like this and then like this from your home to reach your school, what would be the corresponding distances and displacements traveled, right? So you walked perfectly to the right, and then you turned exactly to the left here, right? So this is a right angle. Let's also give you this information. So what would be the distance and the displacement associated with your journey? So the distance would actually be just the total length that you walked over while undertaking this journey. So that was the 600. That was the 600 from the home till this corner, and then from the corner to the school. So the distance would be 600 plus 800, making it a total of 1400 meters worth of distance covered. But if I ask you the displacement, remember that when we were talking about displacement above as well, we said that it is the shortest distance between the 2 points. So this is your starting position, this is your ending position. The school is your ending position. Now this is a pretty easy concept also to understand, that the shortest distance is always one in a straight line. And let's look at an example to understand this. Let's say you are going to jaywalk, not endorsing jaywalking, but let's say you have made up your mind to jaywalk and cars are moving very fast on this road from left to right and you need to get to the other side. What path would you adopt? Would you go in a fashion like this or something like this, or how would you go? And this is something that you guys would also agree with me, that unless you're drunk, you would go straight down, because this is the shortest distance, right? This perpendicular distance is the mathematical term. So the shortest distance is if you would walk in a straight line, right? If you go in some other way, that if you go in a direction like this or something like this, and maybe like just stand around watching the cars zoom past you, then it's probably not a very wise decision if you want to live. But the shortest distance would be that if you just travel in a straight line. So here as well, from the home to the school, the displacement would be a straight line. This is going to be the shortest distance covered. So for example, you know that you are going to cover some distance here, but if you had a jetpack, all you would do is switch on the jetpack, rise above the roof of your house and just whiz all the way to the school. Because think about it, that distance you know is going to be shorter. So now we actually need to calculate this side of the triangle, which is the right angle triangle. We know these two dimensions, so we can use Pythagoras theorem here. So 600 square plus 800 square under the root is going to be the displacement, right? And this is going to turn out as 1000 meters, right? Or 1 kilometer. So this is the shortest distance from the home to the school. Strictly speaking, because this is a vector quantity, there must also be a direction associated with this, and there is. It's this angle. So you can use high school trigonometry to figure out this angle. This angle alpha can be calculated using tan. So this is going to be tan inverse of the vertical, 800 upon 600. This turns out to be 53.13 degrees. So you would give your answer like this, that the displacement from the home is 1000 meters at an anti-clockwise angle of 53.1 degrees from the horizontal, right? So this is how you would actually formulate your answer in its entirety. Now we'll also be drawing up a table of differences between distance and displacement. So let's say you have distance on the left and on the right you have displacement. So what are the key differences excluding the definition? So one of the major differences, and if the examiner ever asks you the difference between distance and displacement, the one-liner is that distance is a scalar, right? It doesn't need direction, but displacement is a vector quantity. Another very important difference is that distance does depend on path, but displacement does not depend on path. What I mean by this is also evident in the definitions. And what I mean by this is the displacement, if you think about it, was just the shortest distance between 2 points from some sort of a reference, right? So it just depends on the points then. It doesn't depend on the path. What I mean by this is, for example, if we have 2 points, let's say this is A, this is B, we want to go from A to B. Now one possible path I'm going to outline here is that maybe you can go like this, right? You go from A to B. Another path would be maybe something like this. This could also be another path, and you can have many more paths like this, right? So for each of the path, the distance traveled would depend on the path, which is why we actually think about roads when going from one place to another place, because we are undertaking some journey, so we will be traveling some distance, right? So maybe through this squiggly path, maybe the distance would be a bit more, maybe a bit less in this one. But the displacement, we also saw this via an example, is just the shortest distance, right? And it's always in a straight line. So this purple one is what the displacement would look like, irrespective of the path, right? It doesn't depend on the path. Whatever path you take between A and B, no matter how you go and you just reach B, your displacement would be the same even if you had taken any other path. So displacement does not depend on the path, but distance does. Now one similarity between them is that both of these are measured in meters, right? Both of these will have the SI units of meters. These are one of the only similarities because both of these are types of lengths. Now some other differences that we saw in the examples above is that distance in itself can only be positive or zero, right? If an object has never moved since its inception, then it will never have traveled any distance. But even if it moves just a bit, even if just someone comes along and nudges it, it will have moved some distance, right? So distance can either be zero or it can be positive. Zero if you don't move, positive if you move in any direction you will, but it just depends on the movement. On the other hand, displacement can be negative in addition to being positive and zero, right? So it could be negative or positive or zero. So again, it could be zero if it never moved. It could be positive if it moved at a certain distance in a certain direction from that origin, and it could be negative if it moved in an opposite direction to whatever was specified as positive. And we saw that above as well. Here, when we were moving opposite, when we were not actually moving, when we were actually towards the left of the origin, right? Because right is what was defined as positive. So when we were to the left of the origin, the displacement was turning out to be negative. So displacement can be positive or negative or zero, whereas distance can only be zero or positive. Similarly, something that follows directly from this is that the distance can only increase, right, or stay constant. So it can increase or stay constant, right? So even if, for example, if it traveled some distance and then it stopped moving, so the distance would stay constant, right? Or if it starts to move, it's going to increase. It's never going to reduce. I don't know why I said it like that, but I meant to say reduce. Next, similarly from this follows the idea that displacement can either increase or stay constant, and depending on where you're moving, it can also decrease. So it can decrease or increase or stay constant. So if you have these ideas very clear in your mind, then studying the graphs is also going to be a walk in the park for you. So we talked about the displacement being positive or negative. One very important idea which follows from this is that the sign of displacement, right, whatever sign it has, could be positive, could be negative, shows where you are with respect to the origin, right? So if, for example, in our example above, example number 1, if you were to the right of the origin, the displacement was positive. When we were to the left, the displacement was negative.